In this video, we're going to look at the following topics: velocity, acceleration, distance time graphs, velocity time graphs, mass, weight, and gravity. So first thing, velocity. Speed is not the same as velocity. However, they are both measured in meters per second to the -1 or meters divided by seconds. Speed is a scalar quantity. It shows how fast an object is moving or going. For example, if a car is moving at 30 miles per hour or 20 meters per second. However, scalar quantities only show magnitude, so the size, with no regard to direction. So there's no indication in direction in them examples. Velocity, however, is a vector quantity. It shows both magnitude and direction. For example, if we have a look at it now, the car is moving 30 miles per hour northwest. Northwest indicating the direction. So other examples of vector and scalar quantities include displacement, velocity, acceleration, force, weight, and momentum are all examples of vector quantities. Distance, speed, time, power, energy are all examples of scalar quantities. So let's look at first of all at speed. Speed is distance divided by time, which you can use the following formula for, where d is equal to distance in meters, t is equal to time in seconds, and if you want to figure out what the unit for speed is, remember that speed is equal to meters divided by seconds, or because distance divided by time, so that's meters/seconds, so meters per second. An example of this: a cat runs 20 meters in 35 seconds. First of all, find its speed, and secondly, how long it takes to run 75 meters. So you can pause the video here if you want and have a go at this question. So speed is equal to distance divided by time. We are trying to figure out speed, so we don't know the answer to that. Distance in the question is 20 meters and time is 35 seconds. Submit this into your formula and you'll get that the speed is 0.57 meters per second. So that is the solution to A. Now let's try and figure out B, where time is equal to distance divided by speed. This time, the distance we're looking for is 75, so 75 divided by the speed we calculated, which was 0.57, and that is 131 seconds. And if we try to convert that to minutes, that would be 2 minutes and 11 seconds. Next thing that we're going to look at is acceleration. Acceleration is how quickly you're speeding up. So acceleration is not the same thing as velocity. It is measured in a different, it measures how quickly the velocity is changing in a period of time, and has a different unit, which is meters per second to the -2. If you're wondering where this unit comes from, remember that meters divided by second is equal to meters to the meters per second, or meters per second to the -1. Essentially, accelerations is that meters per second divided again by second, so that would be meters per second -2. A formula for this: so acceleration is the change in velocity divided by the time taken. When you hear the word change, think of the symbol delta, which is our triangle here, and that always represents final minus initial. So it's the final velocity minus the initial velocity is the delta v, the triangle and v symbol that you see, divided by time will equal the acceleration. So another way to write this is that a is equal to v minus u divided by t, where a is acceleration, v is final velocity, u is initial velocity, and t is time taken. and acceleration is measured in meters per second to the -2. Velocities is measured in meters per second to the -1 or meters per second, and time taken is measured in seconds. So an example of this, if you want to pause the video, you can, to try and do this example. A runner accelerates steadily from 2 meters per second to 6 meters per second in 5.6 seconds. Find its acceleration. So here we are going to try and find out the acceleration, so we don't know the answer to that. V is the final velocity, and that is 6 meters per second. U is the initial velocity, which is 2 meters per second, and T is the time taken, which is 5.6 seconds. We submit this into our formula, and what you get is 4 divided by 5.6, which is 0.71 meters per second to the -2. That is our acceleration of the runner. Next thing that we're going to look at is distance time graphs. So, on a distance time graph, distance goes on the y-axis, time goes on the x-axis. For this example, my distance will go from 100 to 600 meters, and our time will go from 10 to 80 seconds, or 0 to 80 seconds. In a distance time graph, if you get a straight line, this represents a steady speed. So, for example here, if a car went up to 30 minutes and it took 20 seconds, and if it's a straight line, it did it at a steady or constant speed. If you get a flat line across your graph, this represents that the object is not moving or it's stationary. Okay, if we look at our y-axis, you can see that that line is in line with the 300, so the car wouldn't have gone past 300 meters. It has stayed there for 20 seconds. If you get an upward curve, this represents acceleration in a distance time graph, and a downward curve means deceleration. These curves represent that the velocity of the object is changing, hence why you get a curve. And then finally, if you get a line going back the way, it means that the steady speed in opposite direction. So at the top of that line, just beside the word deceleration, you can see that the object was 500 meters. But in about 15 seconds, it has gone down to 0. So that means that the object has moved from 500 to 0, so it's gone on a steady speed in the opposite direction, or returned to its initial position. Be familiar with all of them 5 steps. Next thing that we're looking at is the steepness of these lines. So as you can see here, I've included a line which is steeper. The steeper the line is, the faster the object is moving. And if you calculate the slope or the gradient of this line, it will equal speed. So if you remind you that to calculate slope is y2 minus y1 over x2 minus x1. Try and find the slope for these two lines if possible. So the next thing that we're going to look at is a velocity time graph. Please be aware not to get confused between these two types of graphs. Velocity again goes will go on your y-axis, and time again goes on your x-axis. Here the scale that I will use for the velocity will be from 0 to 50, and for time it's 0 to 80. With a velocity time graph, a straight line represents acceleration and a constant acceleration, and where a flat line represents a steady speed. An upward curve means the acceleration is increasing. Again, I've included a second steady speed. So from the first steady speed, you can see that the car was moving at 30 meters per second for just under 20 seconds. Then it increased its acceleration until it reached about 45 meters per second, and it stayed like that for another 15 seconds. When you get a straight line going back the way this time, this means it is decelerating. If you calculate the slope of a straight line in a velocity time graph, it will represent acceleration. And a reminder that the area under this graph will allow you to calculate the distance travelled. So let's have a go at this. For a velocity time graph, the area equals the distance travelled. So for this example, a car is travelling at a constant speed of 20 meters per second for 3 seconds. So here we have a velocity time graph. You can see that the straight line or the flat line in the graph represents that the car is moving at 20 meters per second and it's doing this for 3 seconds. This is the area we want to calculate. So the area under the graph will be the distance travelled in meters. And if you look at this, that area looks like a rectangle. So an area of a rectangle is equal to width times length. So where we have our length and our width. So for this example, the length is from here to here. The width is from there to there. So our length is 3 and our width is 20. 0 to 20. So we submit this into our formula and you get an answer of 80 meters. And this is the distance the car travelled. However, not all velocity time graphs look the same. So the next example that I've included is if that the car was going at a constant acceleration. So the area under the graph is equal to the distance again. This time the area is shaped like a triangle. So the area of a triangle is equal to half the base by the perpendicular height. So the height as indicated as show, and the base indicated as in the diagram. So the base is equal to 3, the height is equal to 30. So submit this into our formula and you get 45 meters is the distance travelled by the car. Now, what would happen if the area was under a curve? So again, we have our velocity time